Hello, welcome to the channel. We are continuing our integration by part sequence, and the link to a playlist which contains all of the videos on this topic is in the description down below. In fact, we are finishing our sequence of integration by parts, namely this section, and as you may note, problems get a little trickier and time consuming. Nevertheless, let's see what we have today. It's x times arcsec of x. And for this integral, we'll use integration by parts technique again. We'll apply it here in the following way. We'll take arcsec function as the function we'll find derivative of, and x times dx as the function we'll find an antiderivative of. Now, keeping that in mind, we write u is equal to arcsec of x, and dv is x times dx. Now, du will be 1 over absolute value of x times x squared minus 1 dx, and v in this case will be x squared over 2. Now, for some of you, I believe the derivative of arcsec of x might seem a little bit strange because it has, and it's a function that is not seen a lot in undergraduate courses. Nevertheless, at some points you are facing it, and it's better to know its derivative. Perhaps I'll make a video on how to compute its derivative, but as a clue for some of you, you can do this by writing arcsec of x as arc cosine of 1 over x, where x, absolute value of x, is greater than or equal to 1. And in this way, computing the derivative of arc cosine of x, which is known 1 to lots of you, you can easily find the derivative of arcsec of x. Now, not going too far from our topic, we want to have the form of u times v minus v times du. And it's equal to, while explaining how to derive arcsec of x, I don't remember if I mentioned this or not, but it's also the value that you should remember at some point. Not that hard it is, and especially along with other inverse trigonometric functions, you may find some patterns to remember it. Alright, now we have x squared over 2 times arcsec of x, which is 1 over 2 times x squared times arcsec of x, minus, now we can write 1 over 2 out of an integral again, because we have now this product and 1 over 2 is a constant, so we can write minus 1 over 2 times an integral of x squared over integral of x times square root of x squared minus 1 dx. Now at this point we can easily write this integral as 1 over 2 times absolute value of x over square root of x squared minus 1, just cancelling these two without forgetting absolute value. Okay, now at this point of this problem we can do the following. To deal with this absolute value, we may write the answer for x is greater than equal to 0. Well, we can do it actually like x is greater than 0, x is 0, and x is less than 0, and then compute the answer for each case. Then we have, again, this stays the same. Well, it's better to write it here, this as well, minus 1 over 2 times, now here we have three integrals, right? X dx over x squared minus 1 dx 0, and an integral of minus an integral of, or just minus x dx over x squared minus 1. Alright, so basically these two are the same things, except this one being with the minus sign. And now we'll compute this integral as a remark. the integral similar to this one we computed in the previous video when we were evaluating the integral of arc cosine of x. I'll probably attach the link to that video as well in case you want to watch it. As of our integral now, we have an integral of x times dx over square root of x squared minus 1. We can do this in a standard way, writing u is equal to, or just some other variable, y is equal to x squared minus 1, then dy will be 2 times x dx. In this case, because we have x times dx here, like expressing x times dx in terms of dy, it's 1 over 2 times dy. And then substituting this to our integral, we would have an integral of, well, 1 over 2 times the integral of dy over square root of y. And this has the value of y to the power of minus 1 over 2 plus 1 over the same thing here. It's just 1 over 2 here in the denominator and 1 over 2 in the numerator as a degree of y, so it's square root of y over 1 over 2. And since these two, they cancel out each other, we have square root of y, and y was, remember, x squared minus 1. Because of this, we have square root of x squared minus 1. With the computed integral, it has this value, and in the previous video I believe it was 1 minus x squared. Because of this, we would multiply this by minus 2x. That's why in the final answer we had minus there. You can solve that integral as well on your own, like with square root of 1 minus x squared, like x to dx, and look to the previous video to get the solution. And as I mentioned in the previous video, it's not the way you would always solve these integrals, and especially because when you see such a structure, the first thing that should come to your mind is that the derivative of square root of some, say, omega is 1 over 2 times square root of omega, right? And from this point, you should think that, okay, if you have square root of omega squared minus 1, its derivative will be of the form 1 over square root of omega squared minus 1 times the derivative of what's inside, because it's a composite function, chain rule. Here we are, 2 times omega d omega, okay, without writing differentials for now, and here we also had 2, so basically it's square root of omega squared minus 1. So these are the things that, if you're pretty experienced enough, you would notice that if you have this kind of a structure, the derivative of a function, what's inside, is the same as what we have here, up to the constant, of course, like 2 or some other values. So you should get the idea that you can make use of it, and it would drastically save your time. Okay, I will just mark this as a better approach. And now we can continue writing our integral. So just to remind you that we've computed that integral of this thing is this one, which gives us the feeling that this thing with a minus is the same as this with a minus. Now, finalizing our answer, let's copy this and try to write it in a more neat way. Now, for this integral, we have square root of x squared minus 1. For this one, we have minus square root of x squared minus 1. And for 0, it's 0. I didn't mention this, but just if you put 0 here, the integral will turn into 0. So, in fact, we won't have anything here. Okay, now we can leave our answer like this. But if you in your answer sheet or in your exam paper write this using the sine function, I believe you might get some bonus points or just respect from your instructor. So for any case, I'll also make this as a remark. We have a sine function. It's written as follows: sine of x is equal to 1 for x is greater than 0, 0 for x is 0, and minus 1 for x less than 0. In short, it just determines the sign of the given value. Well, as you can see now, we can write our result using a sine function. It's, by the way, I've just wanted to write it using a sine function, and because of this I didn't include constant here. Like, if you are taking your final answer as this one, you should write constant here. Also, as a matter of fact, we should write x is bigger than 0, x is less than 0, x is 0. Now, in a more neat way, it's just x square arc secant of x minus just 1 over 2 times sine function of x times square root of x squared minus 1 plus some constant c. It's our final answer. Here it is. Alright, quick overview. We've noticed using integration by parts here. Then this perhaps was new for some of you. Then just dividing this to 3 cases. Well, here I also forgot to write x is bigger than 0, x is less than 0, and x is 0. Yeah, then we computed this integral using the straightforward way, but there's also a brief and better way to compute it using just some observations. And finally, after we had the final form of the answer, we expressed this using the sine function, which looks concise and neat. Alright, if you have some further questions, feel free to write them in the comment section below, and see you on the next videos. Bye.